Irodov problem number 1.70. A horizontal plane with the coefficient of friction K supports two bodies, a bar and an electric motor with a battery on a block. A thread attached to the bar is wound on the shaft of the electric motor. The distance between the bar and the electric motor is equal to L. When the motor is switched on, the bar, whose mass is twice as great as that of the other body, starts moving with a constant acceleration W. How soon will the bodies collide? Okay, let's start with the diagram first. So we have this surface, we have a bar whose mass is 2m, and then we have an electric motor, okay, and it has a cord that attaches this bar with mass 2m. This battery plus electric motor's mass is m. Okay, this battery is switched on, it starts to wind up this attached thread, and this guy starts moving with a constant acceleration W towards it. Okay, the coefficient of friction here is given as K. Okay, so some friction is there. Now just think of this for a moment. When you are pulling another body towards you, yes, the other body moves towards you, but let's just, like, putting aside the physics, just think of the other body. If it is double your mass, then you might also move towards that body. That's exactly what will happen here. This battery will also start moving, let's say with some acceleration A, towards the mass 2m. Okay, so now that we know what is happening, let's draw the free body diagram for each of these bodies. So for mass 2m, we can write there is 2mg, there is a normal reaction, let's say it's N1, there is this tension in the string T, and because 2m is moving that way, relative motion is this way, so friction will oppose the relative motion. So F is this way, and we can indicate that this body is moving with acceleration W. Now looking at the mass m, we have mg, we have normal reaction N2, we have tension in the string which is pulling this in this direction, and then this body is moving that way, so friction will be opposing motion. So friction, let's call that F dashed, is on the other side. Okay, so now that we have this, let's I missed to indicate that this body is accelerating with acceleration A that way. Okay, now we can write the equations of motion. So tension minus friction is responsible for 2m masses acceleration, which is W. Now in the vertical direction, N1 is equals to 2mg, and there is kinetic friction, so F is equals to Kn1, so F is 2kmg. Okay, from this one we can write tension minus F dashed is equals to the acceleration of the mass m, so m times A. Now in the vertical direction we can write N2 is equals to mg, and F dashed is kinetic friction is Kn2, which is Kmg. Now my goal is to find this acceleration, because the combined effect of these two accelerations will tell me how quickly these two masses come together. It was also given in the problem that these two initially are at a distance L, and the question is to find out how soon, what's the time it will take for these two masses to collide. So let's find A. Everything here is known except for tension. So if I subtract, maybe this is, let's say, call equation 1, this is equation 2. If I subtract 1 from 2, so tension and tension will get cancelled out. So T minus T minus F dash minus minus F. So we have F minus F dashed MA minus 2MW. Okay. Okay. Now F is 2kmg, F dash is kmg, MA minus 2MW. 2 kmg minus kmg is kmg, and m is common between everything, so we can discard m. So kg is equals to a minus 2w, or a is equals to kg plus 2w. So we found a. Okay. Now relative acceleration between these two masses, which is the acceleration of approach, we can write w plus a. Okay, so which is nothing but w plus kg plus 2w, so which is kg plus 3w. Okay. Now this relative acceleration, let's say this is a dashed. Okay. Now we know for uniform acceleration, constant acceleration, we can use this formula s equals ut plus half at square. Now because I have already used a, let me just write a dash t square. Now s is what? The length to be covered. Initial velocity u is 0, and this one becomes half a dash t square. So kg plus 3w t square. Or we can write t square is 2l by kg plus 3w. Or finally we can write t is root over 2l by kg plus 3w. So that is our answer.